In this video, we are going to discuss few problems on Taylor's and Laurent series. First problem, expand log of 1 plus z by 1 minus z at z is equal to 0 using Taylor series. In this method, first you should remember the formula. First, in step 1, we have to write the Taylor series formula. F of z is equal to f of a plus f dash of a by 1 factorial into z minus a plus f double dash of a by 2 factorial into z minus a whole square plus f triple dash of a by 3 factorial into z minus a whole cube plus etc. Okay, in step 1 we have to write the formula, okay, Taylor series formula, and then we are going to find all the derivatives, f dash of a, f double dash of a, f triple dash of a, one by one, and then substitute in this formula we will get the required Taylor series. Okay, given f of z is log of 1 plus z by 1 minus z, which is equal to, we can write log of 1 plus z minus log of 1 minus z. If we write in this form, we can easily differentiate. Okay, f dash of z is equal to 1 by 1 plus z plus 1 by 1 minus z. We know that the differentiation of log x is 1 by x, the same format only we used here. Here log of 1 plus z is there, differentiation of log of 1 plus z is 1 by 1 plus z, minus, actually here minus sign will come, 1 by 1 minus z into 1 minus sign will come, written directly here plus. Okay, and then find f double dash of z. Okay, f double dash of z, once again differentiate with respect to z. Here d of differentiation of log x is 1 by x. No, what is d square of log x? Second derivative, which means minus 1 by x square. Third derivative, d cube of log x is 2 by x cube. Okay, the same format only here we are going to use. This 1 by x form means here minus 1 by x square form, that is 1 plus z whole square form. Here also minus will come, minus 1 by 1 minus z whole square into 1 negative sign will come, that's why written here directly plus. Okay, and then next third derivative, which is f triple dash of z is equal to, next third derivative 2 by x cube. Here actually we have to, here plus sign is there, no, that's why here minus 2 by 1 minus z whole cube will come, into 1 minus 1 negative sign will come, minus to minus plus, directly written here plus. Okay, 2 by 1 minus z whole cube, and then find the values for at z is equal to 0. In the question he has given clearly, expand this log of this term at z is equal to 0 using Taylor series. First you calculate f of 0. Substitute in this equation z is equal to 0. Here we will get log 1, value of log 1 0, here also we will get log 1 value 0, that's why we are getting here f of 0 equal to 0. And then find f dash of 0. F dash of 0, substitute here z is equal to 0, here also 0, we will get 1 plus 1, that is 2. In this term put here 0, here also 0, we will get minus 1 by 1 plus 1 by 1, that is 0. Here f triple dash of 0 is 2 by 1 plus 2 by 1 will come, that is 4. Okay, after finding the derivative, substitute in the formula. F of, actually for general formula is f of a. What is a here? A is 0. F of 0 plus f dash of 0 by 1 factorial. 1 factorial is 1 only, into z minus 0, that is z, plus f double dash of 0 by 2 factorial. The value of 2 factorial is 2, into z minus 0 whole square, that is z square, plus f triple dash of 0 by 3 factorial. The value of 3 factorial is 6, into z minus 0 whole cube, that is z cube plus etc. Okay, and then substitute here all the values. F of 0 is 0, f dash of 0 value is 2, substitute here into z, plus f triple dash 0, f double dash value 0, then substitute f triple dash value here 4 by 6 z cube plus etc. If we here first term 0, omit this one, 2z plus second term, third term also 0, 4 by 6 is 2 by 3 into z cube, which is the required Taylor series. Okay, next problem. Expand f of z is equal to cos z about z is equal to pi by 3 in Taylor series. given f of z is cos z, we know that the differentiation for this cos z, first derivative is minus sin z, second derivative differentiation of sin is cos, here one negative sign is there, that's why written here minus cos z. F triple dash of z is differentiation of cos is minus sin, already we are having here one negative sign which is positive, okay. And then find f of pi by 3, okay. We have to calculate all the values at z is equal to pi by 3. F of pi by 3 means cos pi by 3 1 by 2, and then minus sin pi by 3 is minus root 3 by 2, and then minus cos pi by 3 is minus 1 by 2, sin pi by 3 is root 3 by 2, okay. And then substitute all the values in the formula, we will get the required Taylor series like this, okay. Next problem, if f of z is equal to 1 by z minus 1 into z minus 2, about z is equal to 0, valid in the region, modulus of z is equal to 1, 1 less than mod z less than 2, and then mod z greater than 2, okay. In this problem, using Laurent series method, we are going to expand this one. Here we are going to use the binomial expansion formula. First one is 1 plus x whole power minus 1 is equal to, we can write 1 minus x plus x square minus x cube plus etc. Then second one, 1 minus x whole power minus 1 is equal to 1 plus x square plus x cube plus etc. If this formula applicable only for if mod x less than 1, here also, otherwise we can't use this formula, okay. If we want to use the binomial expansion formula here, in the denominator we need single term only, then only we can use the formula here, okay. First, using partial fraction method, we can split into two parts, which is 1 by z minus 1 into z minus 2 equal to, we can write a by z minus 1 plus b by z minus 2, equation 1. And then this can be written as 1 is equal to a into z minus 2 plus b into z minus 1, and then calculate a and b values by putting z is equal to 1 in this equation. If you put z is equal to 1 here, the second term will be 0. In the first term, we will get here minus a. Left hand side 1 is there, therefore a is equal to minus 1. Then put z is equal to 2 in the same equation. Left hand side 1, first term becomes 0. 2 minus 1 will be 1, that is b. Therefore, b is equal to 1. Okay. Now, substitute a and b values in equation 1. We are getting this form. A is minus 1 here, b is 1, substitute here, and then now we have to take the given region. First one is mod less than 1. F of z is here negative sign is there, no, bring it to the denominator, it will be 1 minus z minus 1 by see here already in this, here we are going to use the binomial expansion formula. If you want to use the binomial expansion formula means the mod here is z we are using, mod z should be less than 1, already given condition mod z less than 1 only. Mod z less than 1 means obviously modulus of z by 2 is also less than 1. Okay. In the first term already we are getting the formula format in the denominator. Okay, 1 minus z is there, you no need to do anything. In the second term only, in the place of z we need z by 2. Okay, z by 2. According to that we have to take outside the value. Here in the place of z we need z by 2 means we have to take outside from this minus 2 common. If we take minus 2 common means we will get 1 minus z by 2. Okay, this step only important, only one step, thereafter we can solve easily. And then the denominator term 1 minus z goes to numerator, it will be 1 minus z whole power minus 1. Here also minus 1 by 2 into 1 minus z by 2 whole power minus 1. And then apply binomial expansion formula, which is in the form of 1 minus x whole power minus 1. Instead of x, here z is there, 1 plus z square plus etc. Here here also the same formula we used, minus 1 by 2, 1 plus z by 2 plus z by 2 whole square plus etc. Okay, first one completed. Second one is 1 less than mod z less than 2. This can be written as 1 less than mod z one term and then mod z less than 2 another term. First we have to write less than 1 form, okay, then only we can use the binomial expansion formula here. This can be written as 1 by mod z less than 1. Here also z by z mod z less than 2 can be written as mod z by 2 less than 1. Okay. Now we can take this f of z is common for all the region, 3 regions. In the place of z we need 1 by z in the first term. Okay. Here we need 1 by z form in the place of z, which means from this term take outside z common. If we take outside z means we are getting here 1 minus 1 by z form, plus from the second term in the place of z we need z by 2 form. Z by 2 form means we have to take outside common minus 2. If we take outside common minus 2, we are getting the place of minus 2 1 will come, then minus z by 2. Okay, this step only very important. And then as usual denominator value goes to numerator, it will be 1 minus 1 by z whole power minus 1 minus 1 by 2 into 1 minus z by 2 whole power minus 1, and then apply binomial expansion formula. We are getting the series like this. Okay, 1 minus x whole power minus 1 formula form it. Okay, 1 plus 1 by z plus 1 by z square, here also 1 plus z by 2 plus z by 2 whole square plus etc. Okay, third one, the given region is mod z greater than 2. First you write in the form of less than 1. This can be written as 2 by mod z less than 1. Okay, write less than 1 form. Okay, the place of z we need 2 by z. Okay, in the first term this is our f of z. In the first term write 1 by z form. Here in the place of z we need 1 by z, which means from this take outside common 1 z. If we take outside z common means we are getting 1 minus 1 by z, plus in the second term we need 2 by z in the place of z. Take outside 1 z common, we are getting 1 minus 2 by z, and then the denominator value goes to numerator, it will be 1 minus 1 by z whole power minus 1. Here also 1 minus 2 by z goes to numerator, 1 minus 2 by z whole power minus 1 form, and then apply binomial expansion formula. We are getting the series like this. Okay, next problem. Find the Laurent series of f of z is equal to 7z minus 2 by z into z minus 2 into z plus 1 valid in 1 less than modulus of z plus 1 less than 3. Okay. If you want to apply binomial expansion formula here, first we have to split into 3 terms this one with the help of partial fraction method. Okay. Write in this form a by z plus b by z minus 2 plus c by z plus 1, and then calculate the ABC values. Okay, calculate the ABC values. We know that how to find the ABC values. This can be written as 7z minus 2 is equal to a into z minus 2 into z plus 1 plus b into z into z plus 1 plus c into z into z minus 2. Okay, in this equation put a z is equal to 2. If you put a z is equal to 2 means left hand side we will get 14 minus 2 is equal to first term 0, second term also 0, we will get only the middle term b into 2 into 3. Therefore, 14 minus 12 will be 2 will be 12, 2 3s are 6, 6b, therefore b is equal to 2 written here. Already you know very well how to apply partial fraction method. Now and then put a z is equal to minus 1. If you put a z is equal to minus 1 means we can eliminate first and second term easily. Left hand side 7z is there, minus 7 minus 2 is equal to, we can write first term, third term values are 0, b into minus 1 into what is sorry, first and second term 0, substitute in the third term, c into minus 1 into minus 3, minus 7 minus 2 will be minus 9, this becomes 3c, therefore c is equal to minus 3. Okay, the similar way we can find a also by putting z is equal to 0. Substitute z is equal to 0, we will get 7z will be 0, we will get only minus 2 in the left hand side, and then if we put z is equal to 0 in the second and third term will be 0. In the first term we are getting a into minus 2 into 1, therefore A is equal to 1. Okay, substitute these values in this equation, in equation 1. Okay, f of z is equal to, f of z is nothing but this one given function. A is 1, 1 by z, B is 2, 2 by z minus 2, C is minus 3 by z plus 1. Okay, the given region is here 1 less than modulus of z plus 1 less than 3 only. If we have z means, modulus of z means, we can easily solve the problem with the help of binomial expansion formula. Okay, for our convenient purpose, let us take u is equal to z plus 1. Okay, if we take u is equal to z plus 1, we can rewrite the equation like 1 less than mod u less than 3, because u is equal to z plus 1. For our convenient purpose only we are taking in this form. Anyway, the final answer we can give in terms of z only. And then now we can write, this can be written as 1 less than mod u one term, mod u less than 3 another term. From this we can write 1 by mod u less than 1 and mod u less than mod u by 3 less than 1 another term. Okay. Now take our f of z. What is our f of z? This is our f of z. After applying the partial fraction method, we are getting in this form. Here also substitute z is equal to, you convert into u, write in terms of u, then only we can easily solve the problem. From this u is equal to z plus 1, we can write z is equal to u minus 1. Here substitute z is equal to u minus 1 written here. Here z is equal to u minus 1 means u minus 1 minus 2 will be minus 3. In the third term z plus 1 is there, u minus 1 plus 1 is u, we are getting in this form. And then in the first term, in the place of u, we need 1 by u, because here 1 by u less than 1. Okay, 1 by u, we need 1 by u here, which means from this term take outside common u. U common means we can write 1 minus 1 by u form. In the second term we need u by 3. In the place of u, we need u by 3. Okay, from this take outside 1 minus 3 common, we will get minus 3 into 1 minus u by 3 form. In the third term, you no need to do anything, already we are having only 3 by u. Okay. Now denominator value, this term goes to numerator, it will be 1 minus 1 by u whole power minus 1 minus 2 by 3 into 1 minus u by 3 whole power minus 1 minus 3 by u. Okay. Now apply binomial expansion formula here, which is in the form of 1 minus x whole power minus 1 formula format. Then apply here 1 plus 1 by u plus 1 by u, fully positive will come, 1 by u plus 1 by u whole square plus etc. minus 2 by 3 into 1 plus u by 3 plus u by 3 whole square plus etc. minus 3u. Okay. Now we are going to replace here u by z plus 1. Okay, in the final answer. Right here 1 by z plus 1, in the place of u put z plus 1, here also z plus 1, 2 by 3 into u is z plus 1, here also z plus 1, then in the last term minus 3 by z plus 1. Okay, that's all.